Welcome to Sketching with Hardware. This is the first video introducing the course, and you may have seen the wiki page, which is up here, where we have most of the information. And in the next 10 minutes, I'm going to explain why we run the course and what the goal of the course is. So the goal is to get students, get practitioners excited about creating functional hardware they can use for various reasons, including user studies, including to communicate their idea. And I've brought here one thing that I just picked up from my desk. This is a future alarm clock, and it doesn't really look like this, but it has all the components it will contain, and I can write the code and I can try it out. I can run studies in my bedroom with it. So let's get started. So the big question is, why sketching with hardware? Why do we want to sketch with hardware? A lot of people say building hardware is expensive, it's time consuming, just use some Play-Doh, build it up, or do a paper prototype, will be fine, talk to the people, you'll get it out. Our experience is that paper prototype and Play-Doh only gets you so far. There's a certain point when people need to experience it, when you need to have sensing working in order to really understand whether it's working or not, or what you need to make it working. And a few years back, I wrote an article, Understanding and Researching Through Making. So the idea is you really have to build it in order to understand how to use it, what really the challenges are. And in this article, there are three ways of making functional prototypes. And I go into some of the details, and the sketching with hardware is targeting one of these types specifically. So if we create functional prototypes, there are a number of ways, but there are three ways that are sort of very dominant, and you find them in the literature. One is you repackage things that are off the shelf. And I have one example, which is what we see here. This is the loop. It's out of the Mesh project. And what we have here is, this is an iPhone in a new casing. To the person using it in the museum, it is a loop. It's something you go over, and it offers augmented reality. It offers an experience, which is very different from holding a phone to it. It has a handle, it has a certain touch and feel. It goes with the museum. So this is one way. You use a device that's existing, and what you do is you repackage it. So making the functional component is just programming an existing part. In some cases, you don't even need to program it. The main effort is in repackaging. This could be either a CNC cut, as we see it here, or it could be laser cutted, or it could be 3D printed. The second part, and that's represented by the picture here from the group in Ulm. This is basically, we build systems, and there are two ways of systems. We build a system that consists of typical components we find out there. In this case, this is a projector, this is a depth camera, and what we build is we put everything together. And what you see here, that's in my view a very good example, and there's a lot of tradition in HCI in doing this. So the idea is you have a clip which you can put to your belt or to your rucksack, and it projects something on the floor in front of you. And in order to experience this, to see how other people react, they build this, but instead of having a clip, this is a full backpack. There's a computer with a laptop in there, laptop battery. There is a camera, a projector camera unit you wear overhead. But by building this out of standard components, they were able to experience how it feels to have such a device. And now comes the last part, and that's mainly what we look at in this course, building custom hardware. So building your device, you have an idea, it needs certain sensing, it needs certain displays, it needs certain functionality, it needs certain actuators, and you build it from scratch. Why is this interesting, and where does it situate in this spectrum of prototyping? So what I have here is, there is that space where we create functional prototype. And this is very different from the low fidelity prototypes like sketches, mockups, Lego, Play-Doh, paper prototypes. If we are in this phase where we have a lot of ideas and we want to quickly iterate to narrow down our ideas, this is really great. This is sort of the way to go to. You don't want to build an a functional electronics prototype for something where you don't really know whether you want it or not. So we're in that phase. So here in this place, we're narrowing down the number of ideas we have. And then we come up to a point where we think, oh, this is a great idea. And a lot of research we see stops here because it gets really hard to transfer this. And we argue if you don't do this part, if you don't really build it, it is really hard. Your results are probably not very valid. If you go to a user with a bit of Lego and said, look, imagine this is an alarm clock that senses your breathing. Would you like it? And I think you get very, very interesting responses, but I believe a lot of them are not very valid. So our argument is you have to build it at that point. So it's not replacing low fidelity prototyping. It is after you have done low fidelity prototyping, you want to really validate your ideas, your concepts. And that's where functional prototypes come in. And this helps us to narrow further down what we need, how we create the interaction with it. And again, sort of having this in this classical functionality versus size appearance. And so what we have very often, we have a paper sketch which is neither offering functionality nor it looks like the product. And then we have the final product that is completely product-like because it's the product and it has the full functionality. And now this one is the area where, let's say, we do a 3D print that really looks like the real thing, but it doesn't work. This is very important to understand how people can hold it, etc. And then there is the idea of having the electronics on a breadboard where you can really try out the full functionality. And what we start in this course, we start here and we show you how to move sort of this way up, how to make it more look like the final product. And sometimes we are going sort of from both ways. We do the 3D printed mock-ups, moving this way, and we do sort of the electronics moving this way, trying to get something that comes very close to the product. It may have very different durability, it may be not washable, it may only hold the battery for, or the battery may hold only for a few hours, but we can create the experience. And this is really this part, what we talk in this course. As I said, here there is some electronics and it's still on the table here. And we are really interested in giving you the skill to build custom hardware. And the learning goal, it's being able to transform your idea for an interactive smart object or an interactive device into a functional prototype that can be realistically experienced. So it should really work and people should be able to experience this. Why would you want to have something like this? Why do we want to have this? And what we have here is we want to communicate our idea in detail. That's one point. We want to allow someone to experience our idea, how it will be, how the product will feel like when it's functioning. For ourselves, we want to understand the challenges in building and using it. From a research point, it's very often we want to create realistic studies and have results that are really generalizable, that will hold for a product. They go well beyond what we can do with a paper prototype. And the final part, that's what I'm quite excited about. It should provide a rough blueprint to get it implemented. So let's take this example again, my alarm clock. Once I have this ready, once I have it programmed, I can see it works. And perhaps I have also a 3D print with how it looks like. I could go to an electronics engineer who is specialized in miniaturization, who is specialized in making it cheap. I could fly to China. I could talk to people. I show them what I have here. They can see what I mean. They really see what it is. And they can rebuild that functionality for a real product, which I can sell them. This is sort of why we want you to get prototypes built. And those are the very different goals we aim at. And with this, we are already sort of right into the course. Here, if you look at the course page, there are different tutorials, and we'll go into them. And the course has two parts. The first part is you go through the tutorials and you do the individual tasks, and I just talk you quickly through them. So the individual task is get the ESP running, get an LED blinking, connect it to serial line. Basically, get the stuff up, get it working, try it. The second one is working with outputs, have an LED blink, have sort of an RGB LED, have a servo moving. Then doing the input side, reading analog inputs, reading buttons you can press or knobs you can turn or different lights. Then building a mini system where you connect a sensor to a display that's showing something. And then you build another mini sensor where a system where you connect a sensor to an output, in this case, for example, a slider or a podi, like a slider or a knob to something that turns. And the final one is do some networking, that you can connect things over the internet. So you have a device here, and you have a device there, and they can communicate to each other. Once you have this, you have the basics to get your project going. And in the second part of the course, we run a group project. So 2, 3, 4 people together build a system. You develop an idea that you want to build, and you go all the way building it, that it's functional, and you can demonstrate in the end that it's working. And here, having a quick look, so the important pages, as at the individual tasks, and the project topic for this course, summer 2020, it is connected objects. That's something we have very often, or a variation of that topic. Then we have the tutorials. There is one tutorial that shows you how to get things up and running. Each of the tutorials has success criteria. So once you have done the tutorial, you can check, do I know this? So this is the basics where we get the modules up and you get an LED blinking. Then we have digital I/O where we get output and input. Then we have analog input, and there's usually a video. There are some explanations. Watch the video, and then it should be straightforward to do the examples. Then we have something how to connect the display. Sometimes we have also linked other people's tutorials in here. Ours are also on YouTube, and you'll find them there. And then there is one on how to do auto run. This is if you build a smart device, whenever it runs, whenever somebody plugs it in, whenever somebody connects it to the power, it should automatically run. And we show how to do that and also how to do a boot selection. And if you have done those tutorials, you have a very good understanding how to start. We use MicroPython, and they are moved from traditional Arduino to MicroPython because our experience is it's much faster to prototype and it's much easier to do connected objects and do more complex examples. And we have a hardware list where we have the components. So there is a so-called LMU box. Students at LMU get this, where there are a lot of components in there. You can see what components are in there. But if you do it by yourself, look at the hardware list. There's things that help. But if you want to get started, it's enough to have a ESP32 or ESP8266 and an LED and perhaps a few wires. Then you can already do many of the tutorials we were talking about. And we have also a page with known issues. There is some problems with the PWM output. There is some issues with the labeling on the ESP32 module we are using. If you come across a problem, don't hesitate, put it into the wiki, and everybody is welcome to contribute to the wiki. As I said here, there's the hardware list, and there's still some of the hardware pieces missing, like the servo, but I show you just one, for example, the stereo amplifier. So there's typically a description about the object, then how we connect it electrically to the ESP chip. Then there is some code that shows how to use it. And then there is the tutorial video that relates to it. So if you find something else, if you find another tutorial that's helpful, just link it in there. We would find that really helpful. And on a final note, we had run the course before, and these are things people build. That was sort of still when we used the Arduino. And the idea is here it was about games that create an experience for the person playing it, but also for the bystanders, like fairground games. And you can see here sort of, this is not necessarily something you want to have in your living room, but from the front side, it looks very much like the real thing. So that's the idea. Create something that you can experience and that you learn how to use it, how to build it, and that you could communicate to an electronics engineer what you really want and ask them to make it. And with this, there is also a list of all the videos so you can have a look. And yeah, have fun, try it out, and hopefully you get as excited as we do.